All right, so today, guys, we're learning about the laws of exponents. If you're in Math 8, you can go ahead and title pages 82 and 83, Laws of Exponents. And if you're in Math 1, you're going to title pages 96 and 97, Laws of Exponents. So this is the same lesson for both classes. They'll just be on different pages in your notebooks. Okay? So let's go ahead and get started. The first thing that we need to explore is what an exponent consists of. So we have what we call the base. So we're going to use an example, let's say 3. And we're going to call 3 the base. And of course, we're going to need an exponent. Let's say this exponent is 2. We know the exponent's written up, above, to the right. This is our exponent. Okay? And this entire thing, the base and the exponent together, is what we call a power. All right, so now let's look just for a second at what the base is actually telling us. So the base is the number that you are going to multiply. Or we also know that to be the factor. All right, and the other thing then we're going to look at is the exponent. All right, that exponent tells us how many times to multiply the base. That's pretty much a review there. We've done that stuff before. You've seen that. So now let's go ahead and look at multiplying powers with the same base. Okay? Zoom in a little bit. All right. So when you multiply powers that have the same base, we're going to follow a specific rule. We're going to keep that base the same and add the exponents. All right. So we're going to look at algebraically, so just with letters or variables, and then we're going to look at why it works and do some examples together. Okay, so algebraically, if the base A is raised to the power, the exponent m, and we're going to multiply it by another base a to the exponent n, the rule tells us that we're going to keep that base the same, and we're going to add the exponents, so m plus n. And now let's look numerically and see why this works. So I'm going to use an example, let's say 9 cubed, or to the third power, times 9, keeping the base the same, to the second power. So broken down in expanded form, that looks like 9 times 9 times 9. That's that first little piece there. And we're going to multiply that then times that second portion, 9 times 9, because there's only 2 of them. Okay? Well, we have then 9, and how many times did we end up multiplying it? 1, 2, 3, 4, and 5. 9 to the 5th power. All right, so let's keep looking. Let's look at some examples. All right, so the first, example 1a, we're going to look, we have all of the same bases, so we already decided that we're going to keep that base the same. Our base is 7. And now we need to identify our exponents. We have to the 5th, to the 8th, and since there's nothing with that 7, it's an understood or invisible 1. Okay? So now our rule is to add our exponents together. Well, we have the exponent 5 plus the exponent 8 plus the exponent of 1, which is 14. So this is my exponent. So my final answer is 7 to the 14th power. Example 2. Okay? We can identify that we have the same base. We have -3 as our base. So let's go ahead and write that. We're going to keep that the same. -3. And we're going to keep it in parentheses to know that that -3 is actually what's going to be raised to an exponent. All right, and now let's identify our exponents. We have 2 and 4. Well, 2 plus 4 is 6, and that's going to go up as our exponent. So our final answer is -3 to the 6th power. Example 1C is a little bit different because it's a little bit more complex. You'll notice first that we do not have 3 of the same bases. They're going to be different, okay? So the first thing you're going to look at is the coefficient. Remember, coefficient is the number that is in front of the variable. So let's look at our coefficients. We have this 3, we have a 12, and we all know if there's nothing in front of this x right here, it's an understood 1. Okay? So when I don't have the same bases, what I'm going to do is, just like you normally would, we're going to multiply those 3 bases together. So I have my 3 times the 12 times the 1. Well, 3 times 12 is 36, times 1 is still just 36. That's perfect. That's going to be my coefficient in my final answer. But let's continue. That's obviously not all of the problem here. You'll also notice that we have x's. We have x to the 5th, x to the 7th, and x, again, all by its lonesome. If there's nothing there, it's an understood 1. So let's kind of rewrite that so we know what we're looking at. We have x to the 5th times x to the 7th times x to the 1st power. Well, what is our rule again? When we all have the same base, we're going to add our exponents. So 5 plus 7 plus 1 is 13. Keep the base of x to the 13th power. Now we're going to combine these together, and we're multiplying. This is multiplying powers with the same base. 36 x to the 13th. And that's your final answer. Okay? All right, moving on. Raising a power to a power is the next thing that we're going to look at, which is a little bit different. All right, we have a rule yet again. Our rule for raising a power to a power is to multiply the exponents. So algebra, why it works. If we have a raised to the m times the n, so that's a power here to another power, we're going to multiply our exponents. A m times n is just mn. Let's look at why it works. 9 to the 3rd, all raised to the 2nd power. 9 times 9 times 9. There's one of those, and I'm multiplying one of these 2 times. Okay, so times another one. 9 times 9 times 9. Well, how many 9s do we have? We're multiplying 9 6 times. So 9 to the 6th. 3 times 2 is 6. All right, let's work on an example. We're going to kind of pick up the pace a little bit here. Okay? So we have this base to a power raised to another power. What are my exponents? 5 and 3. I'm going to keep that base and multiply my exponents. 5 times 3 is 15. So my answer is 2 to the 15th power. Example 2b is a little bit different because I have another coefficient in here, just like we saw in example 1c. Okay? I'm going to actually take this to the third power and break it down to the 3 and bring it down to that z squared thing. Okay? Well, we know that 3 to the third power is 27. That's going to be our coefficient in our problem. And now let's rewrite what we have left. We have z squared brought to the third power. Okay, so z is our base, 2 to the third power, or raising our exponent to an exponent. 2 times 3 is 6. So combine your answers. 27 z to the 6th. Okay. This next one here is a little bit more in depth. We're going to look at this first part. 2 is going to be brought to that 4 and to this x to the 6th. Well, 4 squared we know to be 16. And now we have x to the 6th raised to the second power, which is x, multiply your exponents to the 12th. That's going to be one part of our answer. Let's look at the second part. This 2 is going to be brought to the x. This 2 is going to be brought to the y to the 4th. And now let's break that up there. Okay, so we have x to the second power. Well, if there's no exponent here, it's an invisible 1. So x to the first to the second power is going to be, multiply your exponents, x just squared. And then y we have already to the 4th. We're going to multiply the whole thing, raise it to the second power. Keep your base of y. We're going to multiply our exponents. 4 times 2 is 8. And that's going to be another part of your answer. All right, so let's break it down. Let's see if we have everything simplified. So then we have 16 x to the 12th times, because there's a space, there's just nothing in there. So we know if it's sitting next to each other, it needs to multiply, times x squared times y to the 8th. Do we have everything as simplified as we possibly can? Not exactly. We have this x to the 12th and x squared. Well, now we're going back to what we originally did, the multiplying rule. Our multiplying rule, or the product rule, is just to keep the base and add the exponents. I didn't touch the 16, so we're going to keep it. There's a same base of x. I'm going to add my 12 and my 2 to make it x to the 14th. And nothing is changing with that y, times y to the 8th. And that's our final answer there. And because I'm running out of time in this video, I'm going to start a new video for the dividing powers with the same base.